Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at salinity and how that affects the density and freezing points of the oceans. First of all, salinity is a measure of the amount of dissolved salts in seawater. To measure that, there's several ways you can measure it. We're going to use the term PPT, which stands for parts per thousand. In other words, if you had 1,000 molecules of water, one of them would be salt if you had 1 ppt. Or if it was 32 ppt, then you would have 32 molecules of salt for every 1,000 parts of water. Or 1,000 parts of 1,000 of everything. So it really would be 32 parts of water and 68 parts water. Okay. The other way you can measure it is in grams per kilogram, meaning if you had a kilogram of water, which is about a quart of water, how many grams of salt have been dissolved into that? So grams per kilogram. So then one of the main questions is, how can the salinity of the ocean change? Well, the basic way it can change is by changing the amount of water in it. You can't change the amount of salt in it very easily. You'd have to dissolve salts and get them into the ocean. So the main way is that water either leaves the ocean or gets added to the ocean. Of course, if water removes from the ocean, that's a weird way to say it, if water leaves the ocean, then that means we're going to have a higher percentage of salt left behind. You've probably seen this after you go to the beach. If you go in the ocean, when all the water leaves your surfboard or your shorts or whatever, there's often a little bit of salt left behind. At that point, it's 100% salt. So if that happens to a smaller degree, if just some of the water in the ocean evaporates, we'll end up with a higher salinity. Okay, so somewhere that is warm but doesn't get a lot of precipitation would tend to have a higher salinity, like the Mediterranean Sea. Okay, it's kind of trapped there. The water evaporates, leaving a lot of salt behind, and it's one of the saltiest places in the oceans. Second way that can happen is when water freezes. So if you're at the poles and water freezes into ice during winter, forming more ice, that leaves behind salt, making it saltier. Of course, the opposite is true as well. If we add water to the ocean, then it's going to lower the salinity. There'll be less salt in the water if there's more water. So the two ways we can add water, one is precipitation. So if you're around the equator, there's a lot of precipitation at the equator. A lot of the water that evaporated around 30 degrees latitude gets carried to the equator and then rises, and so we get the rain there at the equator. And so when a bunch of water is added through precipitation, then we end up with a lower salinity. The other option is when summer comes around and the ice at the poles melts. Well, all that water that had been taken out, that is going to be added back in. And so all that water will decrease the salinity. So it'll be less salty because we added more water. Okay, so now, how does that affect the oceans? Well, when you have a higher salinity, the water is going to be more dense, because a molecule of H2O has a mass of 2 hydrogens. They each have 1. Oxygen has a mass of 16. So a molecule of water has a mass of 18. Whereas sodium chloride, if we look at the sodium ion, which would have been separated once they get into water, you could say ionized, the sodium would have a mass of 23, and the chlorine would have a mass of 35.5. And so those are both of those numbers are significantly bigger than 18. And so if we have salt in the water, that's going to make it more dense. It's going to be heavier because the parts take up about the same amount of space. And so if we take out a water and put in a chlorine, well, we just doubled the weight of the water, or of that spot. Okay, so when we have salt in the water, somewhere around 33 parts per thousand. We're going to increase the mass of the water, the density of the water is a better way to say it. And what's that going to do? If water is more dense, it's going to sink. So places where the water is more dense, it's going to sink and cause a downward current, and where it's less dense, it's going to rise. Now keep in mind that temperature also affects the density of the water, and so those two things combined. When you have cold, salty water, like in the winter, when ice is freezing in the Arctic, that's going to cause cold, very salty water to sink to the bottom. And that's what draws the North Atlantic Current and the Gulf Stream and a lot of those things. The last thing that I want to talk about is how salinity affects the freezing point. Most of you know that water freezes at 0 degrees Celsius. Well, when we add salt in there, it makes it a little harder for the water molecules to connect and make what are called hydrogen bonds. And those bonds really bond together to form that ice. And when other stuff gets in the way, it makes it a little bit harder for it to form into ice. And so we get what's called a depressed freezing point. The freezing point of salt water is about -2 degrees Celsius. That'll affect what temperature we have at the bottom of the ocean, because, of course, if it gets colder than really about 2 degrees Celsius, it starts to form those bonds and become less dense. Ice is less dense than water because of those hydrogen bonds, and so it begins to float to the surface. So the coldest, the most dense temperature of water is about -2 degrees for salt water. Is about 2 degrees for salt water, and then as it rises near the poles, it can cool down, or as it cools down below 2 degrees, it rises, and eventually it can reach -2 degrees or so and freeze at the surface of the water to form the ice floating on top of the oceans. All right, this has been the Scientific Adventures of Beardman studying salinity and its effect on the oceans. We'll see you next time.